Hello guys, so in this question it's being asked to draw a velocity versus time graph of a stone thrown vertically upwards and then coming downwards after attaining the maximum height. So what's happening? So there's a stone, it goes up, it's thrown up, so it will go up like that, will attain this height and then start coming down, right? And it will hit the earth, so going up and going down. So let's analyze the motion. So what's happening at t equals to 0? Before we start solving this problem, let's fix the coordinate system first. So let's say this is our positive direction, so anything which is directed towards the sky will be positive. So at t equals to 0, my initial velocity was, let's say, some u. Okay, initial velocity was u, so it will be plus u. Why? Because it was thrown up. Then acceleration was negative g. Why? Because the acceleration always acts downwards when the body is thrown upwards. So the direction of acceleration is this. Okay, so since it is downward, so I'll be taking negative as a value of acceleration as negative g. Okay, now at the highest point v will be 0. So if you see, for the up ongoing motion, or when body is going up during this phase, I can write the first equation, v is equal to u minus gt, right? This is coming from the equation, since v equals to u plus at. Now here plus a is minus g, so hence, right? Now how to plot this part? Mathematically, this is a straight line. Why? Because it is of the form of y is equal to mx plus c, where mx is time, c is u, m is minus g, and y is v. So if you plot this, let's plot it here. So let's say this is, sorry. Okay, fairly straight. So let's say this is time t. Okay, now this is my velocity axis. Now, so if you there are either through the knowledge of coordinate geometry, you know that it is a straight line, or what you can do is you can put values and find out the corresponding value of v. Put value of t and find out the corresponding value of. Okay, so let's say I am putting t here and v here. So when t was 0, v was, when you put t in this equation, you'll get values of v. So when t was 0, v is equal to u, isn't it? When t equals to 1, v is equal to u minus g. When t equals to 2, it's u minus 2g. So let's say u was 100. Okay, so let's take u as 100. So it was 100, it will be 90 if g is, and let's say g is 10. 90, this will be 80, and then 70, and like that, right? If you see, if you plot now 0, let's say this is 100, this becomes 50. Okay, so this is like 90, 80, 70, 60, right? So 0, so this is the point. Let me just change the color to highlight it. So this is the first point, this would be the second, this would be the third, fourth, fifth, and so on. So if you see, this is nothing but straight line going towards 0. And if you see, at some point in time, this will become 0. So velocity is becoming 0 at this time, right? So this depicts that it is at the highest point. Okay, velocity is becoming 0. Now what will happen? Now after reaching the highest point, the velocity will change its direction. That's what is shown here. So now the velocity is like this. So it will take a negative value. Why? Because our towards the sky axis was positive. So now velocity will continue to take negative value. So as time will increase further, velocity will become more and more negative. Why? Because now the magnitude of velocity will start increasing, isn't it? So here, if you see, let's take this part now. So here, after this point, let's fix again, or let's make time t equals to 0 again. Though it is not 0, why? Because our 0 was here, but since it's a linear time is changing linearly. So what I mean is, I can very much again say that this is time t equals to 0 for the new journey, and whatever is the final time here will be taken care of. Now what I mean is, here now the equation will be v is equal to u. Now here u was again 0. Why? Because instantaneously it will be at 0 rest. So 0 and then minus g t. Now this t starts from 0 again, right? But in this curve, this time has already been spent, and now I'm saying I'm starting afresh. So it is starting from here. Okay. Now if you again plot this v and t, let's say t again, v again. Okay. So now if you put t equals to 0, you will get v equals to 0. So clearly now you are shifting your t's coordinate or starting point origin here. So when t equals to 0 here, from this point, after 0 second, the velocity was 0, isn't it? Again at this point, after 1 second, velocity will become minus gt, or in case t is 1, so it will be minus g, that is minus 10. So hence, now when t is 1 with respect to this origin, so t is 1 with respect to this origin here, and velocity minus 10 will be somewhere here. So this is going like that, and it will continue like that, isn't it? So when t equals to 2, it will be minus 20, t equals to 3, it's minus 30. So eventually the final curve would be something like this, t, v. So this goes like that. This way, yeah. Now what are the characteristics of this curve? So the time taken to go from ground to the highest point will be equal to time taken to cover the same distance back. And second thing is, the magnitude of this initial velocity was u. So the final, the velocity of the particle just before hitting the ground will be minus u. Okay, so the velocity with which it went up, when it comes down, it will have the same magnitude but opposite direction. You can see when it was thrown up, the direction of velocity was like that. When it is coming down just before hitting the ground, the velocity is like that. So hence, but the magnitude remains the same, only the direction changes. So this is the VT graph for a body which is going up and coming down. The point, or let's say the question for you would be, can you draw a displacement time graph for the same motion? Think about it.